Welcome back to All This Math. This is Professor Parker, and for this lesson, we're going to be solving an equation with fractional coefficients, which basically means our coefficients are fractions. All right. So 5/3. I mean, we can think of 5/3 as a coefficient because we can think of it as 5/3 x to the 0 power. Since there is no x term there, x to the 0 power is equal to 1. So that's why we could think of 5/3 as a coefficient, or you could just think of it as a constant, right? So we want to, what I could say is we're solving an equation that has fractional coefficients and fractional constants in it. So it basically just got a bunch of fractions in it, right? 5/3 plus 2/3 x is equal to 25/12 plus 5/4 x plus 3/4. Now, since we're trying to solve this or find a solution, we're trying to find what numerical value for x we can use, which will make this a true statement, because we're trying to find the truth, because math is all about finding the truth, right? So what number goes in the place of x to make this a true statement, to make the left side, after we do the math, equal to the right side after we do the math, all right? Now, first things first, when I see a problem like this, I'm not trying to mess with them fractions. So I get rid of the fractions, all right? So when you see an equation like this with a bunch of fractions in it, do yourself a favor. Unless they all got common denominators already, and you can just combine them, like you might think, oh, be careful though. You might think you could just add these two together because they got common denominators, but you can't, because these are not like terms. This has an x in it. This does not. You can't add these together. So I know somebody might be sitting there like, oh, we could just make this 7/3 x. No, you can't do that. That's got an x in it. This does not. You cannot combine these two. Same thing over here. Even though these have common denominators, that's got an x in it. This does not. You can't combine those, all right? So don't fall for the okie doke, all right? But like I said, when I see a problem like this, I want to get rid of the fractions. They got to go, and the fractions got to go. Now, this is how you do it. And I'm going to tell you this, so that way, anytime you see an equation that's got a bunch of fractions in it, you can use this method to clear out the fractions. A lot of textbooks call it clearing out the fractions, right? I just call it getting rid of the fractions, because that's going to make the equation simpler, right? Once we deal with all integers or whole numbers or whatnot. You look at, first step is to look at all the denominators. I see a 3, a 12, a 4, and a 4. All right, I just took inventory of all my denominators. Then I ask myself, I kind of treat it like as if I was trying to add or subtract fractions in a fraction arithmetic problem. I say, okay, well, what's my LCD, or my least common denominator? What would that be in this situation? I know that my LCD would be 12. The LCD out of all of these fractions is 12, because 12 is the smallest number that 3 can multiply into evenly, 12 can multiply into evenly, and 4 can multiply into evenly. Because 4 times 3 is 12, 12 times 1 is 12, 3 times 4 is 12, all right? So my LCD is 12. You might want to just write that down. So I'm going to just write it over here. LCD equals 12. Now, why did I figure out what the LCD was? Why do I care? What am I going to do with the LCD? What I'm going to do with the LCD is I'm going to multiply each term in this problem by the LCD. And once I do that, that is going to automatically eliminate all of the fractions. I guarantee you. If it doesn't eliminate all the fractions, then you've done something wrong if you're doing a problem like this. All right, so what I do is I draw brackets around the whole thing. And then I write a 12 outside. And then I'm going to proceed to basically, it's kind of like you're applying the distributive property. Every individual term gets multiplied by a whole 12. Now, watch this, right? You do not multiply the 12 by the numerator and the denominator. Do not do that. That is a very common error. Do not do that. The 12 only gets multiplied by the numerator. The top number, it only gets multiplied by the numerator, which is the top number. Now, think about it like this. 12 is a whole number. But if I wanted to represent 12 as a fraction, it would be 12 over 1. So if I'm doing 12 over 1 times 3/4, I would do 12 times 3 and 1 times 4, right? Notice how that 4 is not going to change after you multiply by 1. So do not multiply 12 times 3 and 12 times 4. Don't do that. Don't do that. That's wrong. Don't be wrong. All right? So let's distribute the 12 to, I'm going to start from the far left though. Distribute the 12 to each term. So 12 times 5/3. So I'm going to multiply the 12 by the 5 and get 60. And then I'm going to have 60 over 3. But 60 over 3 is 60 divided by 3. 60 divided by 3 is just 20. So I write 20 down. Boom. Then I write my plus sign. Then I'm going to do the same thing with 2/3 x. I'm going to do 12 times 2. That's 24. 24 divided by 3 is 8. Right? I got to know my multiplication facts and I got to know my division facts in order to do these problems too. So I got 8x. See? Fraction going. Fraction going. Fraction going. Watch this. 12 times 25. Now, that's a big number. I might not want to do that, right? There's another way I can do this, right? I can also divide first and then multiply by that quotient, right? So I can do 12 divided by 12, which is 1, and then 1 times 25 is 25, right? Or, I mean, if I wanted to put forth the effort, I mean, I know that 25 times 12, well, 25 times 10 is 250, and then 25 times 2 would be 50. So 25 times 12 is 300, right? If we think of 25 as like 25 cents, like a quarter, 4 quarters make up $1. So 4 quarters 3 times is 12. So 4 quarters 3 times is $3. So that's 300. And then 300 divided by 12 would be the 25, right? Or we could do 12 like I did. 12 divided by 12 is 1, and then take that 1 and multiply it by the 25. That's how I get 25. All right? Then I do the same thing with 5/4. 12 times 5 is 60. 60 divided by 4 is 15. So now I got 15x. And then I'm doing 12 times 3/4. So 12 times 3 is 36. And then 36 divided by 4 is 9. So then I'm at plus 9. So what I have now, so now I got an equation that's equivalent to this equation, and multiplying by 12 basically just expanded it, right? So all the numbers are different, but the relationship between all the numbers has remained the same because everything got expanded by 12. This got expanded by 12. It's kind of like, you know, when you take a picture on your phone and you zoom in, you're expanding it. You're expanding the picture, all right? And all of the dimensions got expanded by the same amount, right? When you zoom in, that's what happens. This is what we did here. We just expanded each of these terms by a factor of 12. That's what we did, right? So in case you're wondering, well, how is it the same equation? Well, it's the same equation because the relationship is the same. The relationship between all these terms. So now, what I'm trying to do now is I'm trying to isolate x by itself on one side of the equal sign, preferably the left side, because that's just what I like, where I like to put my x's, on the left side. All right, but I'm gonna combine like terms first. So I'm gonna do this. I'm gonna do 25 and 9, right? Because all numbers are alike, okay? So then I'm gonna have 20 plus 8x. I'm not gonna do nothing with that yet. 25 plus 9 is 34. So I'm gonna write 34 and then plus 15x. All right. So now what I'm gonna do is I like to do a method called transposing. All right. Or maybe I won't transpose. I mean, we got options, right? So maybe I won't transpose. Maybe I'll just do this. Maybe I'll just do, now because I want my x to end up on the left-hand side, just because I like to be able to say x equals something, right? I'm gonna subtract 15x. I'm gonna do it the standard way. I'm gonna do the inverse property of addition or inverse property of subtraction. It's either called the inverse property of addition or inverse property of subtraction, one of those. But I'm doing minus 15x, and then because I do that on the right-hand side of the equation, in order to stay balanced, I gotta do it on the left-hand side of the equation also. So I got minus 15x over here too. These cancel out, that's nothing. And then I got 20 minus 7x is equal to 34. So notice what just happened. I subtracted 15x on the right, I subtract 15x on the left. That's the rhythm. What you do on one side, you're doing on the left side. Just like with dancing, it's a rhythm, right? Just like singing a song, it's a rhythm. Math is a rhythm. Once you get the rhythm of the math gets easy. All right, minus 15 on the right side. Actually, minus 15x on the right side. Minus 15x on the left side. Now watch what I do. I'm trying to get this x by itself on the left-hand side, so I got to get rid of two things. This 20 and this negative 7. This 20 and this negative 7, they got to go. So check this out. I'm going to get rid of the 20 first, right? I could get rid of the 7 first, but in my experience, when you're solving equations, when you get rid of the coefficient of the variable, the problem tends to get messy. And I want to avoid as much mess as possible. I mean, we can do it. It's mathematically correct. We could divide everything by -7 if we want to, but that's going to get messy. You're going to have fractions and when you don't necessarily need to. So what I'm going to do is get rid of this 20 first, because you got to get rid of both, but the order doesn't necessarily matter in which you get rid of it. But typically, what I do and what a lot of people do is they'll get rid of the constant term first. All right, so the opposite of a positive 20 is a negative 20. So the opposite of a positive 20 is a negative 20. So therefore, we're going to do subtraction to represent the negative 20. That's how we get rid of it. So minus 20 on the left-hand side, and we got to be balanced. We got to be balanced. So we're going to do minus 20 on the right-hand side. Cross him out. Bring down the -7x. 34 take away 20. What's 34 take away 20? 34 take away 20 is 14. We got to know how to subtract, and we got to know our subtraction facts. 34 take away 20. I hope you don't need a calculator to do 34 take away 20. I mean, if you do what you got to do, but you want to practice your subtraction skills so that way you'll be able to do that off the top of the head. 34 minus 20, right? The difference between 20 and 34 is 14, all right? Now, one last step. How do I get x by itself? I get rid of this -7. How do I get rid of -7? I do the opposite operation or the inverse operation from what -7 is involved in. -7x means -7 times x. So the opposite of multiplication, which means times, is division. So that means I need to divide by the same exact number in order to get rid of this. And because we're in an equation where we need to stay balanced, we're going to divide this by -7 also. So boom, boom, bring the x down. Because look, -7 divided by -7 is +1. So we have 1x. 1x. 1x is the same thing as a x or just x. So now over here on the right, I'm doing 14 divided by -7, which is -2. Now I believe that to be the correct answer. I believe that x is equal to -2, but I need to check my work. So what I'm going to do is this. I'm going to go back to the original problem and plug in my -2 value to make sure that that works. So wherever my x's are, those are the only terms that's going to change. So I'm going to do 2/3 times -2, which is -4/3. And I'm going to do 5/4 times -2. And notice how I did not multiply the -2 by the 3. I only multiplied the -2 by the numerator 2. I do not multiply by the denominator also. All right? I'm going to do the same thing over here. 5/4 times -2 is going to be -10/4. -10/4. All right? Now, I want to do my calculations on the left side, and I want to do my calculations on the right side, and I want to see if I end up with the same answer. I want to see if my left side is equal to my right side. That's what I want to see. So I got 5/3 plus -4/3. 5/3 plus -4/3 is the same as just straight subtraction. 5/3 minus 4/3. 5/3 minus 4/3 is 1/3. So this left-hand side simplifies to 1/3. Now let's see if we get 1/3 on the right-hand side. I got -10/4 plus 3/4. I got to add these two together because they already got common denominators, right? Right, I'm going to deal with the 25/12 in a minute. -10/4 plus 3/4 is going to be -7/4. These two right here make up -7/4. Now I got to combine that with 25/12. So what I can do is, think about it like this. I'm doing 25/12 plus -7/4. I'm just real particular. Don't mind me. I hate when my fraction bars don't be looking cool. So 25/12 plus -7/4 is the same thing as 25/12 minus 7/4, right? So minus 7/4. So I need an LCD. 12 is going to be my LCD because 12 goes into 12 and 4 goes into 12 too. So this is going to be 25/12 minus 21/12. 12, the 4 changed into a 12 because that's my LCD that I need. Now, where does 21 come from? If I multiply 4 times 3 to get 12, I got to multiply 7 times 3 and I get 21. So 25 take away 21 is going to be 4/12. You got to know how to reduce fractions. You got to know how to reduce fractions. I got 4/12 because 25 take away 21 leaves me with 4, right? But what's the greatest common factor between 4 and 12? It's 4. So that means we divide each of those numbers, the numerator and the denominator, by 4. So 4 divided by 4 is going to be 1. 12 divided by 4 is going to be 3. And we end up with 1/3. So the right-hand side simplifies to 1/3. So in fact, 1/3 is equal to 1/3. So therefore, that is proof. And this is how you check your work. So you never got to wait for your teacher or your professor or whoever to validate you and tell you that your answer is right and your work is right. Always go back and check your work and make sure that you have answers that answer, explanations that explain, and solutions that solve. All right? Because it is possible that you can do all this work, get an answer, but the answer is not right. And how do you know it's not right? Because when you plug it in and do the math, it does not give you a true statement. You might end up with a situation where, like, if you'd have got the wrong answer, you might have had something like 1/3 equals 8,500, something like that, something crazy, right? And you know that don't add up. All right. So I showed you how to do this. Now, the way you're really going to learn it, the way you're really going to commit it to memory is by practice. You must practice. All right. You got to practice. I showed you how to do it, but I mean, it's cool to watch somebody else do it, but you got to get in the game. Math is not a spectator sport, right? This is only meant to guide you step by step. Now you got to go practice. You got to ask your teacher, your professor, whoever, for some practice problems. You got to go online and do a search for some practice worksheets, find those, and get to work. All right? So go get some practice, and I'll catch up with you on the next video. Peace.